We're going to talk about artificial intelligence, and I want to let you know off the start that everything that I'm covering in this lesson is content that I learned in a webinar called Learn AI in 60 Minutes. It was put on by the AI for Anyone organization, which is a really cool organization, and they have a ton of resources. If this is something that's interesting to you, I recommend going out and checking their website. I believe it's aiforanyone.com or aiforanyone.org, but check that out. You can also watch the original webinar if you want to see their full one. Easiest thing is to pop into YouTube, type in Learn AI in 60 Minutes, and you'll see the whole thing where I got all of this content from. But this is just kind of me abbreviating it for my classes. Okay, so we're going to talk about what AI, what artificial intelligence is, how it learns, and then how we can build a better world with AI. And then I'm going to have some questions for you to dive deeper for your assignment at the end. Okay, first thing, I'm going to give you an example of artificial intelligence. This is Google Assistant calling the hairdresser to make an appointment. This is just a minute-long clip, but I think it's pretty cool. Just kidding. Let's try that again.
How can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So there you go. I think what makes this so particularly like artificial intelligence seeming is there's some of those like subtle little things, like she says and but you can also hear the kind of computerizedness of it, like when she says 12 p.m. like that sounds really automated in my opinion. But what really makes this AI, I think, is the fact that when the Google Assistant got a no response, they said, okay, how about a 1:15? That I think was outside of the realm of what was appropriate, because then it's like, okay, if 12 o'clock is not okay and we're getting something outside of this window, then you have to ask, do you have something in this window? So it's kind of a decision. You can kind of start thinking about how would that actually look in a flow chart, making that decision. So you can kind of see that process there. A very simple definition for artificial intelligence that they gave us in the webinar is computer systems doing things that normally need human intelligence. Obviously, in that scenario, a computer is doing that thing. So normally, yeah, you would have only a human would be able to do it. The computer isn't necessarily going to be able to determine that 10 a.m. is okay when noon wasn't okay, and realize that 1:15 wasn't okay. So, and especially having the way that it's speaking, I think really made that feel more artificial intelligence. Some of you guys might not completely buy that as an example of artificial intelligence. We'll get a little bit more into that in a few more slides. Let's first talk about some examples, whether you think these examples are AI or not. So you've got Siri, the microwave, Wall-E, self-driving cars, a coin sorter, Facebook auto tag, and the Terminator. I think most of these are pretty easy to figure out. You probably eliminated microwave and coin sorter right away as not examples, because all you're really doing there is pressing buttons, and then it's just doing something that automatically was already programmed into it. There's no decision making there. And then Wall-E and Terminator, obviously artificial intelligence, obviously not real, but definitely artificial intelligence doing things that humans are only the ones that are normally able to do them. And I know you might be a little bit confused about the Siri and the self-driving car and the Facebook auto tag. Does that really count? So we'll get to that coming up very quickly. So before we move on to that, I think one thing that makes things not necessarily seem like artificial intelligence, like artificial learning, is when it seems so obvious that a computer can do something. So for example, this is a picture of Garry Kasparov competing against the Deep Blue computer, which is not the man sitting there. The man is operating the Deep Blue computer. And that was the first computer that was ever actually able to beat a world-class chess champion. That competition was May 11th, 1997. They played 6 matches, and he won, more matches, and won the final game, which is how he won the whole match. And that was really seen as a huge leap in artificial intelligence and machine learning. And what's I thought was really interesting when I went back and read some more about this event was Garry Kasparov actually was furious when he lost, and he thought that this was that the computer was actually being remotely controlled by another chess champion, that had to be a grandmaster who was running the computer, and that the computer couldn't possibly be advanced enough. And I know we think, well, that's absurd. There's chess games all over the internet that are really advanced. And if you don't have a lot of experience in programming, I think that's where your head jumps to. But you guys have had experience with having to write a program, and you've seen just how difficult it can be to get a very simple task completed, and especially to get a task completed that requires a decision where you don't know exactly what's going to happen next, and you have to program your robot to be able to handle a variety of options depending on whatever information it's being fed. And so when it seems so easy for a computer to be able to do those things, even though, the actual process of it being able to get there required a lot of learning, we call that the AI effect. And basically it's when computers doing things stops seeming magical. Okay. Now we're going to talk about 2 different categories of artificial intelligence. The first one is called ANI, which stands for Artificial Narrow Intelligence. That's what we call it when AI is magical at doing just one particular type of thing. And then AGI, that is when a computer or artificial intelligence form of whatever it is able to do everything that a human can do. And that's called AGI. So let's take a look at some examples. Are they ANI, narrow, or AGI, general? All right, so again, Wall-E, Siri, driverless car, Facebook auto tag, Terminator. Which things here would be considered ANI and which would be considered AGI? So actually the only things here that are AGI would be Wall-E and Terminator. You might have thought maybe driverless car, but really that's about as narrow as Siri is. Siri can listen to what you're saying and then make recommendations on the internet for you. Facebook auto tag can look at different images and determine who is in a person, or which person is in the picture. And a driverless car can get you from A to B, driving around. But none of those things can do everything that a human can do. Only Wall-E and the Terminator can do that. And alas, neither of them currently exist. So ANI, good at one thing, and then AGI is good at everything a human can do. That's how those two are different. Now, both of these are going to be learning from examples. Okay, so that's what they have in common. They both learn from examples. They need lots and lots of examples to get good at something. AGI has the ability to transfer its new skills to a new area. Facebook Auto Tag can't take that information and then translate that into, you know, identifying different types of sports cars, or even being able to do a Google search for you. It can't do that. AGI can transfer skills to different areas. Okay, and then we have ANI versus AGI. ANI does exist today. We have lots of examples of narrow intelligence today, but AGI does not currently exist, and it might never exist. That requires some extremely advanced programming and some extremely advanced abilities, and honestly, I'm a little bit glad that it doesn't exist. It's a little scary when you think about it. Maybe it will never fully exist, that level of AGI, of being able to do everything that humans can do. Maybe things will be able to start getting a little bit more than just narrow than just one thing. But I don't know. I don't know how that's going to work. That might be something that you guys have to work. I gotta pause for just a second. Okay. So now let's compare the actual programming piece. So for a regular computer program, if you wanted to create a program that can recognize tigers in images, you would probably have to put in some rules for the program to follow. So the program could look at the image and say, all right, does it have 4 legs? Yes. Does it have a tail? Yes. Does it have 2 ears that stick up? Yes. Whiskers? Yes. Black and orange stripes? Yes. So if all of those answers are yes, then your program would be able to say, this is a tiger. Problem? Welcome back, Virgil. What if we have this image? Well, we would answer yes to all of those same questions. So we would say it's a tiger again. How is the computer, based on just this image, supposed to be able to determine between tiger and cat? So you could tell, well, the size, but the image alone doesn't really tell you anything about the size. And I don't really know how you describe, like, maybe the shape of the head or dimensions or something, but I mean, it's going to be really tough to discern between tiger and just orange striped cat. So to give you an example of this, I shared a Google form with you that's a game, and this game is, we actually got to play it before doing the webinar, and so I'll show you the results from that. Since I am not giving you that game in advance, I won't be able to look at your results. But so this is an imaginary world. There's this imaginary category of things called digicons. They're not real shapes. This is just for pretend. And they, digicons have there are 3 different categories: Yodas, Fluffers, and Skizzles. And so then your job was to figure out what were the Fluffers and what were the Skizzles and what were the Yodas. So what's really interesting here is if we actually, let's look at the game real quick. Okay, so here's the game. And so what you would do is look at a shape and you would say, okay, what the heck is this? I have no idea. And if you've looked at it already, then maybe that's exactly what you were thinking, like, this is stupid. I don't know what this means. So maybe you said, all right, this is a fluffer. And then in the next picture, I show you that actually that shape was a Yoda. So you're like, okay, maybe this shape is a fluffer. Well, nope, that was a skizzle. Well, since a skizzle's a triangle and this is a triangle, maybe this is also a triangle? Ah, okay, so then that one is correct. And so then as you go along, you can start to see that you can learn what category this is. Okay, so like this, that's a Yoda. And then this weird shape, well, we haven't had any fluffers yet. And this thing, it's round and it's got a red stripe around it. Maybe that's a fluffer. And so then you start figuring out what these different shapes actually mean. And what's really interesting is as you play, as you go along, you're going to get better at it. And then this is actual data from the game when I played it the day of the workshop. And so you can see that on the first 4 questions, we were all failing, but by the last 4 questions, we were almost at a B. So you can imagine that if there were more than just 18 questions, then we would get better and better and better at it. And that's exactly how artificial intelligence learns. It uses examples to get better at being able to discern things. It's my birthday and I had barbecue, I'm sorry. Okay. So now, how would you describe something in words as, is it a Yoda, a fluffer, or a skizzle? Well, hopefully you can see all skizzles are triangles. And all fluffers seem to have red outlines around them. So that helps. And then your Yodas are just kind of these wackadoodle shapes. So you can start to be able to explain rules so that a computer would be able to identify which one is which. Now, when we start getting into something more complex like facial recognition, those rules are a lot harder. How do you discern between Mark Wahlberg and Matt Damon? And especially, what if they aren't just making that facial expression all the time? How does that work? And so you can see how it starts to become much more complex to be able to get a computer to identify between those things. So to make that happen, you have to really use a lot of examples, a lot of data, a lot of repetition to be able to get that to work. So for an intelligent computer program, we don't just have the basic rules, we have to use examples and non-examples. And so, look, little baby tiger, have to identify that as a tiger. It looks like a tiny kitten, but it's tiger. So you get positive examples and then negative examples. And then something else that's really important is the edge cases. So these are things that are almost a tiger, but not quite. And so that helps really to hone in on the ability of the program to make those decisions, having those edge cases where they're really, really close, but not quite. There we go. Then what if some of your data is wrong? Notice we've got some shapes down here that really ought to be Yodas and some shapes that should be fluffers, and these should definitely be skizzles. What do you do if the data is wrong? Well, then your computer is going to be learning incorrect functions. It's not going to work properly. And that can become a really big deal if you have, say, the example that they gave us during the workshop was if you've got a driverless vehicle and it's recognizing something as a tree, but it's actually a person, maybe it's, has had enough examples of people, and so it doesn't recognize that this person could start moving, and that can become a really big problem. And then another issue that can come up with data is what if you don't have enough examples of a particular category? So like here, we don't have enough examples of Yodas to really be able to figure out what the heck is a Yoda. This was actually a really big problem. The example that they gave us was with the facial unlock feature, like early facial recognition software from Google and from HP had a big problem with not being able to recognize people with darker complexions, because in the data that they used to create that program, they weren't using a lot of people who have darker skinned complexions. And so then, those people, like, if you were trying to unlock your phone or something, you couldn't do it. When Apple came out with its facial unlocking feature, they really took care to have a lot of data from people of all different cultures and also all different ages, little ones to big ones to old people, so that it could recognize any face and have a lot more success at doing that. Because a little kid's face is going to be rounder, not as defined, and then an older person, maybe they got lots of wrinkles. And so if you're only looking at faces of people between like 20 and 50, then it's not going to be able to get the younger faces necessarily, and the older faces as well. So it's important to have data that's really covering all of the users, or the possibility of input information. Okay. And then last one is, what if different people have different ideas about what a skizzle is? So maybe these two triangles here, those are in fact skizzles, or in fact Yodas, according to that particular person. And the example they gave us was, for example, in Australian accent, perhaps they're pronouncing words differently than you do in the United States, or than you do in England or in India or wherever else. And so if you've got different accents, then different pronunciations of things could maybe be difficult for Siri to understand. So